PDA 5110 statistics class. We want to talk about frequency distribution. Now, one thing is very important for a researcher to go to the field and obtain raw data. And it is very necessary for a statistician as well to analyze, to arrange the data for man use. In order for every viewers or those who need the data to be able to explain what has actually happened and to know the purpose of that data. In this case, we want to look at frequency distribution table. What is frequency distribution table? In my definition, I say frequency distribution is a way of arranging raw data in tabular form into classes or categories with reference to their sizes or the sizes or magnitude with I've mentioned reference here with their number of occurrence Now, here we say frequency distribution is a way of arranging raw data in tabular form into classes or categories with reference to their sizes or magnitude with their number of occurrence. Meaning that whenever we want to talk about frequency distribution, we must make sure what we are talking about is in tabular form. That is number one. That is, the data we are talking about should be in a tabular form. We must tabularize it. That is number one. Then number two, again, we must make sure we arrange them. And what is arrange? Arrange means to put things in order. That is, we must make sure we put the data in order. And that order means we are going to place it in a tabular form. I've said that here. Then again, we are putting each of the data into their classes or their categories. And at the same time, we must not forget the size or the magnitude of the data. And as well, we must make sure we put into consideration the numbers of occurrence. That is, the numbers of time in which the data appears. the numbers of time in which the data appear. That is my own definition of frequency distribution. Now, there is one thing I want us to understand is this. We see raw data. To a layman, you are seeing this definition for the first time, and you have not come about what is known as data before. You are seeing it for the first time. To you, how do you understand what we are talking here, or what we are saying here, the explanation about frequency distribution here? Now, this takes us to what data is. We say, what is data? What is data? What is data? In my own definition, I say anything or any number that is being collected from the field. Any number that is being collected from the field. It is raw, it is direct. So one is just getting it from the field. But due to the nature of the class, I will say data can be defined. Data can be defined as a collection of facts such as numbers. It could be words. It could be measurement. It could be an observation. And description of things. Description of things. Example, e.g., you can have numbers such as 5, 3, 2, 1, etc. And as well for words, we can have something like Bible. You can have something like table, and all. Again, for measurement, you can have something like kg, that is kilogram. You can have something like foot, and so many other things like that, Then for observation, you may go to the field, you discover one or two things, like maybe in a football match or an event. Whatever you see, you take the record down. Again, for description, you can describe things the way you see it. Now, I want us to read again the definition of data. What is data? Data can be defined as a collection of facts such as numbers, words, measurement, observation, and description of things. That is the way we describe things, or what we see, we explain. That is data. And we can also say it is systematic record. It is the systematic record of certain quantity. It is the systematic record of certain quantity. Now, with this, we've seen data. For a researcher or for a statistician, the data we are talking about, the facts we are talking about, we can actually group them into two. One, ungrouped data, and the other one is group data. Grouped or ungrouped data, or grouped and ungrouped data. For the benefit of the class, I want to explain what we mean by ungrouped data and what we mean by grouped data. Now, in our class again, I want us to link that to this because we are talking about frequency distribution. Now, under this, whatever table we are able to derive or we are able to draw for the ungrouped data will be referred to as ungrouped frequency distribution. And for the group as well, whatever data we are able to analyze or we are able to explain, we will refer to it as grouped frequency distribution. Group frequency distribution. Don't worry, when we get there, we also understand better. Now, let me rub this because of the size of the board. I want to rub this. Now, let's talk about ungrouped data. Ungrouped data. Ungrouped data. Now, when we say ungrouped data, remember in the definition of frequency distribution, we said the way and manner in which we organize or we arrange raw data in tabular form into what? Classes or category. Here now, when we say ungrouped data, whatever data we gather and it's yet to be put into classes or category are known as ungrouped data. Any data we are able to gather and are yet to be put into various classes or categories are known as group data. Now, with the definition, I want to write what an ungrouped data is all about. This is a data given as an individual points. Given as individual points, that is, they are yet to be classified into classes or categories. So they are what? Single point. Example, e.g., we have something like 5, 2, 4, 6, 7. This is an ungrouped data. We only have individual points, that is individual figure. So they are not representing any class, they are not representing any category. So this is referred to as ungrouped data. Now, like I have said earlier, this data, if we are going to put it in a tabular form, if we are going to arrange it in a tabular form now, whatever information or whatever result we are getting from it will be referred to as ungrouped frequency distribution. Will be referred to as ungrouped frequency distribution. So this leads us to what is an ungrouped frequency distribution. What is an ungrouped? The ink of this marker is disturbing. Ungrouped. What is an ungrouped frequency distribution? distribution. Now, don't forget, if we are to explain this, we will say an ungroup frequency distribution display the occurrence in a tabular form. That is, it display the occurrence of individual data. An ungrouped frequency distribution.
Go.
Its distribution display the occurrence of individual data in a tabular form. Without including a group. That is, it consider the individual data instead of group. Now, example is the number we see here, like 5, 2, 4, 6, 7, and on like that. So we are not considering any group. So whatever we are doing is only based on what? On individual data. Now, what is an ungrouped frequency distribution? An ungrouped frequency distribution display the occurrence of individual data in a tabular form without including a group. That is, it consider the individual data instead of group. That is an ungrouped frequency distribution. Now, because of the size of the board, we will try now to collate some data. An example will be given, or an exercise will be given, where we will solve the question. We will now make sure we tabularize any data given, and from there we will still talk about proportion, or we'll talk about relative frequency, and we discuss percentage as well. So these are those things we can do under frequency distribution. So I'm now going to rub this. But before I go there too, I will still need to explain the features. Let me quickly do that. The features of ungrouped data or ungrouped frequency distribution. The features of ungrouped frequency distribution. The features of an ungrouped frequency distribution. distribution. Number one, the data are not large. The data are not large, so they usually have small data, not a very large data. Number two, again, it's used, it means the data under ungrouped frequency distribution, the data here can be enumerated. The data can be enumerated. That is, we can count them. The data can be enumerated. And when I say the data are not large, meaning the data range from between 5 and 12. Between 5 and 12. That is what my lecturer told me. He said between 5 and 12. The data we have been found here. So again, they are not the data are not put into the data are not let me rub this. They are not the data, let me put it this way, does not allow class interval. That is, class interval are not used. The use of class interval does not exist under ungrouped frequency distribution. The same thing goes to ungrouped data. So when we are talking about the table, here we are saying the same thing. So now I'm going to rub this because of the size of the board. Or I may still leave it. I will use the other smaller board to talk about or to discuss the SSRs. Now, we want to go to frequency distribution proper. That is the table, the frequency distribution table. Table here, frequency distribution table. Now, before we go, I will give us the tips or steps involved. Number one, when we are given a data and we are being asked to draw a frequency distribution table, the first thing we need to do is for the tips. One, we must make sure we identify the low and the lowest and the highest value or number. The lowest and the highest. That is the first thing. Then after that, number two, we draw a table. Now in that table, 2i. Under the table, what we are going to have is this. For the first column, in the first column, we impute all the figures, all the values that were given in the data. We put it there, then we tag it X. In the first column, impute the values given in the data. And name it x. Then 2ii. The next one, create another column. And name it tally. Under this tally, we are going to use stroke and strike through. Each number found in the data will be represented by a stroke. When we get there, I will explain further. Then number 2ii. The next thing, create another column adjacent to the second one again and name it frequency. This frequency is denoted by F. These are those things we need to do. But again, at the end of this frequency, 2ib, add the numbers or values in the frequency column. And name it summation F. Or we can just leave it that way. When we get there, we will understand this. Summation F. Just add it at the end of it. That is, we are adding all the frequency together. So with this, we are good to go. These are those things we want to do in the exercise that follows now. These are those things we need to do. Now, let me write the question here. I think we can also see this. Identify the lowest and highest value. Draw a table. Then in the first column, input the values given in the data and name it x. Then the next one is you create another column adjacent to the first one and name it tally. Then the next one is you create another column adjacent to tally and name it frequency. Then the last one will add the numbers in the frequency column. You add everything together in the total. Now, we want to look at this question. Exercise 1. In a book, and I want to read it and write on the board. The exercise, I've written it. Exercise 1. It says a survey of 20 pupils was taken in Fuka Primary School in Lagos. They were the number of times they borrow books from the library in a week. Now, the following were the recorded results. Now say represent. This is the question. Represent the information in a frequency distribution table. Frequency distribution table. That's the question. Now I want to see the data. The data is 1, 2, 1, 0, 3. Yeah, 4, 0, 1, 1, 1. Yeah, 2, 2, 3, 2, 3. We have 2, 1, 4, 0, 0. Now, this is the data. Now, I want to represent this information in a frequency distribution table. We want to represent this information in our frequency distribution table. Now, the first thing we do is this. We are going to draw a table, and that table is going to be named frequency distribution table. Frequency distribution table. Now, let's look at it. Solution. We say frequency distribution table. Now, remember the first one says we should draw a table, and under the table, the heading of the table is this frequency distribution table. And the number 2 information says we are going to create a column for what? For all the data, and we name it X. On the table, we name it X to contain all the data. And don't forget again, the first point says we must identify the lowest and the highest number or value. The lowest number here, our lowest number, denoted by L, equals 0. While our highest number is what? The biggest number, which is 4. Now, we are going to use this range between 0 and 4. Here, the one we have here, we are going to write them here. Start from 0, 1, 2, 3, and 4. We are done with that. And this is the data that we recorded for the student who actually borrowed book in the library for that week, representing the numbers. Now, we want to look at what? The next one is tally. Like I said in my explanation, I said we read through the data given, then whichever one we see from the numbers given to us, we are going to cancel it out and represent it with what? A stroke. We are going to represent it with a stroke. under tally column. Under tally column. Now, the first one is 0. So we look at the data. Wherever we find 0, we are going to cancel it out here, and we are going to denote it by stroke under tally. The first line, we have 1 0. We are going to cancel it out, represent this by 1 stroke. 1 stroke. Then the next line, find another one. Another stroke. The third one, no 0. Fourth one, we have 1. We put it. Then this one, we put it. That is that. We are done with 0. Then we go to the next number, which is 1. The first one, we have 1. Cancel it out. Stroke. Another one here. Cancel it out. Stroke. Here we have 1. Cancel it out. 1 stroke. Cancel this out. Another stroke. When there are 4, and when you now find another one, you are going to strike through to make it 5. This, the fifth one. Strike through. That is 5. Look at another one. We don't have it. We have another one. Then we are going to continue because we have another one from another tally. Here. Cancel it out. Here now. We are done with 1. The next one is 2. Found 1. Cross it out. Here, no 1. Found 1. Find another one. Find another one. Here, 1, 2, 3, 4. Cancel this one out. Yes. You strike through. Then we move to the next one, which is 3. Here, 3. Where do you have again? We have 3 here. We have another one. Cancel it out. Stroke. We don't have again. That is 3. Therefore 4. We don't have any 4 up here. We have 1 here. Cancel it out. 1 stroke. We don't have here. We have another one here. So that is that tally. If you look at it now, there is no number again remaining here. So now we go to the next column, which is frequency. It will be denoted by what? F. Now I said we are going to count the numbers of strokes we have in each tally. Then it will be represented by what? The figure. We have 1, 2, 3, 4. Here we have 4. 1, 2, 3, 4. Then the stroke one. I mean the strike through one. 5. Then plus this 6. Here we have 1, 2, 3, 4. Then plus this one. We have 5. 1, 2, 3. We have 3. 1, 2. We have 2. Then at the end of it all, we have what is called total. 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 Yeah. So now add all these frequencies together. 4 plus 6, 10, plus 5, 15, plus 3, 18, plus 2, we have 20. So this is exactly what we have in the question. This is, we have 20 pupils in the class. So denote all the 20, the occurrence of the 20 students. Yeah, so we are done with the question. That is frequency distribution theory. Don't forget, I said it earlier, we can as well calculate the relative frequency. We can calculate the relative frequency, and as well again we can calculate the percentage. Now let's move to that. Let's go to that. We are going to do that under another question. Now the question says, a teacher gave a test in a basic science to his Form 2 students. Their marks were given below. Draw a frequency distribution table and determine the relative frequency and percentage of each score. Now this, we are going to, the data will be given in the next video. The data will be given in the next video. But this is the question, and this is what we were asked to do. So we are going to represent the data in the frequency distribution table, and as well we are going to calculate our relative frequency and the percentage. So in the next video we are going to do that.